Today I'll take us through a series on shear force and bending moment analysis. But before I start the analysis, I will take us through key supports or reactions which we need to carry out this analysis. Now I'm going to be talking about 3 supports, and those 3 supports I will not give their definitions, rather I will define them in the description, so do well to read about them in the description. Alright, so the first support I will talk about is what we call the pin support. The pin support. Now the pin support looks like this, just like a triangle, something like this. It can also take the shape. Okay, so this is called a pin support. Whenever you see this support on a pin, that's how it looks like. You know it's a pin support. Now, to analyze the pin supports have 2 reactions at the point of occurrence. That is to say, wherever the pin is acting, we have 2 reactions at that point. One is vertical and the other is horizontal, acting towards the point where the support is found. Now, this is what I mean. Let's say we have a pin, and this is A, this is point B, and on this pin we see this support. Okay, so first of all, you identify that this is a pin support. Now, I've told you that in applied mechanics, the first thing we do in applied mechanics whenever we have any problem is always applying the free body diagram. I said this in the first series on applied mechanics when I talked about 2 dimensions. So please do well to follow the 2 dimension series to understand properly. So first of all, we will talk about the free body diagram of the beam. It is now in the free body diagram that you replace the pin support with what? The reactions. Alright, so let's do the free body diagram for this F, B, D. So free body diagram becomes at point A we have a pin. So in place of the pin we have a vertical and horizontal reaction at point A. Alright, so at point A we have one vertical reaction. So we can call this RA, R stands for reaction or force. You can also use F. So RA means reaction at point A, Y signifies vertical. Then we also have RAX. Okay? So we have RAX all at point A because of what? The pin support. So the free body diagram for the pin support depicts 2 reactions, one vertical and one horizontal. Also, we have a pin at point B. So at point B, we also have a vertical reaction. So all this RBY. So RB means reaction at point B. Once again, Y signifies vertical. Also, we have RBS, sorry. Okay, so X stands for what? Horizontal. So this is point B. Alright, so it is important for you to know that whenever we have a pin support on a beam, we always represent it with what? A vertical and a horizontal reaction. Alright, so that is that for a pin support. The next support I'll talk about is what we call the roller support. Now, this is how a ruler looks like. Roller support. Well, for a ruler, you usually find something like this. This is how the shape is. It's either it is running like this, or you can also find it to be in this format. Okay, so when you see this ball bearings, these circles, or a circle like this, it is called a roller support. I will also add the definition in the description below. Alright, so this is what a roller looks like. So for a roller support, the free body diagram depicts just one reaction. But you must always take note, this reaction must always be normal to the surface where the roller is acting. Normal as in it must be perpendicular to the surface where the roller is acting, or it must be at 90 degrees to the surface where the roller is acting. So it is important for you to know and be able to differentiate between a roller support and a pin support. Okay, so let's say we have a beam and we have a roller support on one end. We also have a roller support on this end. I told you it takes different forms. Okay, these 2 forms majorly for roller support. So this is point A and this is point B. And now we need to carry out the free body diagram of the roller support FBD Okay, so we have our beam. At point A, we have the ruler. Rulers must always have their reactions at 90 degrees to the surface. Now, I will explain what this thing means much later. Alright, so we have at point A, we have a reaction. This reaction must be at 90 degrees to point A. And if we check from this point to here, this is 90 degrees. So it means it's a vertical reaction. So this is simply going to give us RAY. So rulers always have one reaction. And that one reaction must always be normal to the surface at 90 degrees to the surface. Okay, we also have reaction at point B, which is also a ruler. So as well, we have our ruler, one reaction at 90 degrees to the surface. So it must always make an angle of 90 degrees to the surface where the ruler is acting. In this case, it's also vertical, so we have R, B, Y. Alright, so let's talk about situations where, let's say we have a vertical beam. We have a vertical beam and then we have the ruler acting on it. Now this is what's going to differentiate the ruler from the beam. So we have this to be point A and point B, and we have this ruler acting at the middle point of the beam. Let's say here is point C. Alright. Okay, so we have this ruler acting at point C, the middle point of the beam A and B. Alright, so in order to differentiate this from the definition, we have the free body diagram. That's for this. Okay, so we have a straight beam of A, point C, and B. Now, we said that the reaction of ruler is always at 90 degrees to the point of occurrence, the point where it is acting. So since it's acting at point C, it must be at 90 degrees to point C. Notice that 90 degrees to point C is simply means that this ruler will be horizontal. So we'll have here to be 90 degrees. Now it's no longer vertical. This is now 90 degrees. So the reaction is now a horizontal reaction. So this is RCS. So notice the difference between a ruler and a pin. Ruler usually makes an angle of 90 degrees to the point it is acting, just like that. See, it is now making an angle of 90 degrees towards this surface. And in this case, the reaction is no longer vertical, the reaction is now horizontal reaction. It's quite different from a pin. Let's say we have a pin on this beam. Let's say it's a pin we have here. A pin is normal always. Whenever we have a pin, it is always a vertical and a horizontal reaction. Always a vertical and a horizontal reaction. So that means for this pin, if it's a pin that is here, it means this is our beam, okay, point A and point C, point B, and this is point C. Alright. So it means at point C we have a vertical reaction, so we can call this RCY. And then we also have a horizontal reaction at point C, RCS. So it's important for you to know the difference between a ruler and a beam and how it occurs on a beam. Alright, so the third and final support I will talk about is what we call the hinge support. So we have the hinge support. Okay, the hinge support looks like something like this, like a doorknob. Okay, this is how the hinge support looks like the knob of your door. That's how the hinge support looks like. Now, when the hinge support occurs on a beam, I will also define the hinge support in the description below. Please take note of that. But if the hinge support occurs on a beam, there are two things that play. There are two key things that play out, and I'm going to tell you what that is. Let's say we have a beam. Let's say we have a beam, and then on this beam we have a hinge support. Okay, and the extent of this hinge is 2 meters, and there's a force of 10 kilonewtons acting on this hinge. So this is point A, and this is point B, and this is point C, where the hinge is acting. Okay, so like I told you, there are two key things that are playing out in the hinge support. The first is this, that the effect of this force, just like when you want to rotate your door, when you want to open the knob of your door, you fling it or you pull it. Once you pull it, there's a rotating force. Now, the first thing you know that the force you apply on the hinge will definitely amount towards, this is called the hinge, this is where the hinge is. So this 2 kilonewton, 10 kilonewton force that you apply to pull the door is having an effect at point C. Alright, so the free body diagram, FBD becomes, okay, for the hinge support. Notice that if I pull the door knob, first of all, the whole weight, which is not this force acting on this point, is acting with felt at the hinge. At the hinge. So it means at this hinge, at point C, we already have this weight having an effect at this point. So at point C, we already have a 10 kilonewtons having an effect at that point. Okay, so at point C, we already have this force having an effect at this point. Now, also, you pull the hinge, there is a rotating force when you pull the hinge to open the door. It moves, it makes a moment, a clockwise moment to open the door. So there is a moment that is made, and moment is simply force times distance traveled. And the total distance it takes the hand of this knob to travel is what 2 meters from the given here, from the given diagram is 2 meters. So moment is simply force times distance. That moment is now 10 times this, which is 20 kilonewtons meter. So it means at point C we also experience the moment. So we have at point C, this point C. At point C we experience the moment of 20 kilonewtons meter, simply because the force moves through this distance to get to the hinge and opens the door, and the distance is 2 meters. So 10 times 2 will give us 20 kilonewtons meter. So this is what plays out. This is how the free body diagram of a hinge looks like. Okay, so we have the 10 kilonewtons force which is acting on this point of the knob. This force is felt, the effect of this weight is felt at the hinge. So we have the 10 kilonewtons force first at the hinge, which is this 10 kilonewtons force. And then when you pull the knob, it goes all the way, making a moment around the hinge to pull the door open. And distance covered is what? 2 meters. Moment is simply force times distance. So we have 20 kilonewtons per meter around the hinge. So this is how the free body diagram of a hinge looks like. Alright guys, in the next video we will start calculations and analysis on shear force and bending moments. I hope to see you in the next video. I hope you find this interesting. Please like and of course subscribe and share to your friends for more subscribers. I will see you in the next video. Thank you very much.